Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This has to do with reflection over the y-axis. I want to approach this algebraically and also geometrically because I think in order to do these kinds of problems, you really need to be thinking geometrically as well. If we were just to look at it from the point of view of the algebra, all that's really required here is to remember the rules for reflections. And so I'm going to put them here. So if you have a parent y equals x, y equals f of x, sorry, and you want to reflect about the y-axis, which is what they're asking for here. So this would be about the y-axis. The child turns out to be f of negative x. So that's all you would have to do. That's all you have to remember. We're going to do that in a second, but I want to put the other axis in there while we're here. So once again, the parent is y equals f of x. And we want to go about the x-axis. The child is going to be y equals negative f of x. So in this particular problem, we had y equal to absolute 2x minus 1 plus 3. And so this is the parent. And the child is going to be, see how this is just a replacement rule. We're just replacing x with negative x. Do you see that? Hopefully that's clear to you. And so wherever you see an x, we're going to replace it with f of x. That's all negative x. So this is going to be y equals absolute 2 times negative x. We're just replacing x with negative x minus 1 plus 3. And if you want to, you can clean this up a little bit and you write y equals absolute negative 2x minus 1 plus 3. So that's the first one here. And if we wanted to reflect this over the x-axis, here's our parent, absolute 2x minus 1 plus 3. The child would be, you're just going to stick a negative in front of the entire expression here. So it's going to be negative with a big bracket here. And then absolute 2x minus 1 plus 3. And that's just going to be negative absolute 2x minus 1 minus 3. So that's the way to do it with algebra, but I think it's important to do this visually. So I'm going to put in this grid, this graphing grid here, and we're going to take a look at this parent function, absolute 2x minus 1 plus 3. I'm going to make an xy table here. And then we'll do a quick graph. So I know that the absolute value function looks like a V. This is going to be a V opening up because the leading coefficient is a positive 1 here. I want to get that vertex, and that's going to be at 1/2. And the way I get that is I just set this, what's inside the absolute value, to 0. So this is going to produce a 3 here for y. And then we'll just go down. We can go down to, let's say, 0 and maybe -1, and then we'll go up to 1 or 2 here. So at 0, you're going to get 4 here. When x is 0, y is 4. So because it's going to be absolute -1, which is 1. When x is -1, it's going to be 6. And then when x is +1, you're going to get 2 minus 1, which is 1, plus 3 is 4. And then 2 times 2 is 4, minus 1 is 3, plus 3 is 6. Okay, so now let's take a look at the graph. Okay. First, I want to just talk about how to reflect about the y-axis. We'll just take an arbitrary point here, and we'll reflect it about the y-axis. Well, what you do is you just look at this distance here to the y-axis, which is 3 units, and the reflection is going to be 3 units on the other side. So that's all it is. That's reflecting about the y-axis, 1, 2, 3. Or if I was down here, say I want to reflect that about the y-axis, it's going to be, the reflection is going to be here. So let's go back and we'll plot these points, and then we'll reflect. So -1, 6, 1, 2, 3, 4, 5, 6. That's going to be a point there. Having a little trouble controlling my stylus this morning. I apologize. I don't know if it's me or if it's the stylus. Anyway, at 0, it's going to be 4. 1, 2, 3. And then at 1/2, it's going to be 3. And then at 1, it's going to be 4. And then at 2, it's going to be 6 here. And so we see we're going to get a nice V-shaped curve coming out like that way. On that side, I'll just pull it up. Oops. Do that again. Get my line in here. Try to get it up like that. Oh boy, that was even worse. Let me see if I could just slide it. Okay, that's a little better, but not much. And get the other line. So that's my original graph. Now, if I want to reflect about the y-axis, remember this was a half here, so the reflection is going to be here. And then you see how it's 4 on either, 3 on 4 on either side of that. So this is going to be here and here. and then six, which would be 4, 5, 6 here. And here, so we're just going to get this. That's visually how we're reflecting over the y-axis. So this point is 2 units out from y, and when it's reflected over, it's going to be 2 units out from y. It's going to be here. That line is not drawn perfectly. This you can see on the original. This is half a unit from y. This is going to be half a unit from y. This unit up here, this one up here was going to be 2 units away. It's supposed to be 2 units away, and this would be 2 units away. I'm sorry for my artistic difficulties here. But this point here is reflected to this point here. This point here is reflected to this point here, and so on. And then the vertex here is reflected over to here. Because this vertex is half a unit to the right, the reflection would be half a unit to the left. Because this point here was half a unit to the right, this will be of 1 full unit to the right. This will be 1 full unit to the left, 2 full units to the right, 2 full units to the left. And that's the way you do it graphically. Now, the other thing we could do, here's our parent. We could put in some values for the child here. We'll use another color. Now notice the y value doesn't change, it's just the x value. And so what you're doing is you just negate the x value. So this would become 1, and then 0, and negative 1/2, and negative 1 and 2. We'll just copy out the same y values here. 6, 4, 3, 4, 6, and then these will match this red curve here. So for example, 0, 4 will be the vertex. Oops, I forgot the half, excuse me. But 0, 4, let's see, that's supposed to be, yeah, 0, 4 does work. So this point here was reflected on itself. It's a little hard to see. And then I had a negative, the vertex was at positive 1/2. Here we go, positive 1/2. 3. This one was originally 1/2. Yeah, this goes to negative 1/2. Negative 1/2, 3. So here's negative 1/2, 3 right here. So all I'm doing, I know it looks more complicated, but all I'm doing here is I'm just negating the x coordinate. It's just negative x here. I just changed the signs. And if you plot these points, you're going to get this red curve here. I just think it's important to understand visually what's going on and not just be like a robot and just plug this in. All the question's asking for is the algebra, which is fine, but I think having the visual context here is also very helpful. So that's why I was doing this. I'm sorry, my stylus is giving me trouble today. Anyway, that's it for this lesson. I'll see you guys again next time. Bye-bye.